So we're going to keep talking about sequences, and we've been talking about arithmetic sequences, which are things like 2, 4, 6, 8, and what we see is that we add 2 to each of the previous terms, so our common difference is 2, and that's an arithmetic sequence. We're going to start talking about geometric sequences, which are a little different. Example of a geometric sequence would be 2, 4, 8, 16. So this one's arithmetic and this one's geometric. And the big idea behind geometric, so a geometric sequence, geometric, okay, it's geometric if the ratios of consecutive terms are the same. So it's a fancy way of saying that we multiply each term by the same thing. I'll show you in a minute what that looks like. The way that we check is we look for this number r. So on arithmetic we looked for d. In geometric we're going to look for an r. R is called a common ratio. And the way we find it is we take one of our terms and we divide it by the term before it. So a2 divided by a1. And that has to equal a sub 3 divided by a sub 2, which has to equal a sub 4 divided by a sub 3, and so on, so that we would say that a sub n over a sub n minus 1 is our common ratio. So the number r, common ratio. It's real easy. Right, so determine if the following sequences are geometric. If so, find the common ratio. Well, one thing you might do is say, well, to get from 2 to negative 6, I subtract 8. Well, that would be great, except that to go from negative 6 to 18, you don't subtract 8. And that's how we would have had an arithmetic sequence. So to check if they're geometric, we want to see what happens multiplication-wise. So to go from 2 to negative 6, we multiplied by negative 3. And to go from negative 6 to negative 18, we also multiplied by negative 3. And another way to check that, if you can't see it easily like that, is to take your, here's your A1, A2, A3. So we'll do A2 over A1. So negative 6 over 2. That's negative 3. And then we'll do A3 over A2. Well, that's 18 over negative 6. 18 over 6 is negative 6 is also negative 3. So we have a common ratio, negative 3. So this is a geometric series. The next one says a sequence whose nth term is 2 to the n. Well, that means there's a sequence, a sub n, that equals 2 to the nth. And so that might seem confusing at first, but you'll see that it's not that bad. So a sub 1 equals 2 to the first, which is 2. A sub 2 equals 2 squared, which is 4. A sub 3, 2 cubed, which is 8. A sub 4, 2 to the fourth, which is 16. So our sequence goes 2, 4, 8, 16. All right, and to find our geometric or our common ratio, if we couldn't figure out what it is just by looking at this, okay, we can take all of our numbers. So 4 divided by 2 is 2. Then we take the next number, 8, and divide it by the number before it. 8 divided by 4, also 2. 16 divided by 8, also 2. So our common ratio is 2. So this is also a geometric sequence. Right? Just like the arithmetic sequences, when we want to find one of the terms, say the nth term, it's not always fastest to just keep going times 2 times 2 times 2. Sometimes it's easier to plug it into a formula. And the nth term of any geometric sequence has this form, a sub n equals a sub 1 times r, our common ratio, to the n minus 1. So the arithmetic sequence has a form and a geometric sequence has a form. We're going to need to know both of those. Okay, again, r is the common ratio So every geometric sequence can be written in the following form. There's A1 and there's A1 times R. Then there's A1 times R squared, which is just RR, and A1 times R cubed, A1 times R fourth, all the way up to A1 times R to the n minus 1. And the formula for finding R, when we need to find it, is real simple. We just do that R equals A sub n over A sub n minus 1. And all that means is we take something like A2 over A1. And that's the same as A3 over A2, just like we did up there at the top. Hey, something else that we're going to do, which it's not in your notes, but we're going to write it in here anyways, is we're going to add in our recursive formula. Remember, recursive is when the term you're finding depends on the term before it. So for the recursive, we're going to have that A sub n equals R times A sub n minus 1. So if I wanted to find the 40th term, and I knew the 39th, which is the n minus 1, I just multiply it by the common ratio and I'd be done. All right, so we're going to go right into a couple of quick examples. Write the first three terms of the geometric sequence. So when it says geometric sequence, you know that it has a common ratio of 1/2. All right, so A sub 1 equals 24. A sub 2 equals 24 times 1/2. So that's 12. And A sub 3 equals 6. So pretty easy. Find the 12th term of the geometric sequence whose first term is 20. First term is 20. That means A sub 1 equals 20. And whose common ratio, R, equals 1.76. Okay, find the 12th term. Well, we have our formula. A sub n equals A sub 1 times R to the n minus 1. So we just plug it all in. So we want to find our 12th term. We have A sub 12 equals A sub 1, 20, times R to the n minus 1, so that's 12 minus 1, which is 11. Now remember, R is 1.76. So we're going to do A sub 12 equals 20 times 1.76 to the 11th. It may be easier to put our parentheses like this instead of a dot because we get confused with the decimal. All right, type all that in the calculator and you get that A sub 12 equals 10,038.5. See, it's not any different than yesterday, it's just a different formula. All right, find the 24th term of the geometric sequence. Well, we start out with our sequence. We know that A sub 1 equals 5. Now we need to figure out our R value, our common ratio. So if we can't do it quickly, we just start dividing one term by the term before it and see what we get. Okay, so we did A sub 2 divided by A sub 1. Then we did A sub 3 divided by A sub 2. We got 3 both times. So that tells me that A sub 1 is 5 and R is 3. So I know that A sub n equals A sub 1 times, we'll do it this way, R to the n minus 1. So we have A sub 24 equals 5 times R to the n minus 1, so 24 minus 1 is 23. So A sub 24, type it all in your calculator, and you get 4.7 times 10 to the 11th, right? Well, that's fine unless you need to know what that really is. So that's 4.7, and then we move the decimal 11 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we go back and we put a 0 in all of these empty spots. Then we go from there, and every 3 we put a comma. So A sub 24 equals 470 billion. All right, last problem. Write an explicit and recursive formula for the nth term of the geometric sequence, then find the 24th term. So just like yesterday, we have a sub 2 equals 6 and a sub 5 equals 162. But we can't find the r the same way we found the common difference. So remember yesterday we just did 5 minus 2 and that was 3. We can't do that today. So with the geometric, there's a little bit different formula. And we actually need to go back and write that in your notes so that you have it. So let's go all the way down here and right in here, let's make a little blank in here, a little box. And we're going to write a sub n equals a sub k times r to the n minus k. Okay, that's going to be our formula for finding r when the terms are not in order. So this is how we find r when our terms are not in order. And I'll show you what that means in just a second. All right, so we have our terms here. We have a2, a sub 2, and a sub 5, but they don't go in order, so we can't divide them to find our common ratio. So we have that formula that I just had you write down. It says a sub n equals a sub k times r to the n minus k. Now you're probably thinking, what is this junk? But don't worry, it's not that bad. The bigger number is our a sub n, smaller number is our a sub k. This is n, and this is k. All right, so we're going to write a sub 5 equals a sub 2 times r, and then n is 5 minus 2. All right, now we know a sub 5 is 162. So 162 equals a sub 2, which is 6r. 5 minus 2 is 3. Now we divide both sides by 6. 162 divided by 6 is 27 equals r cubed. Then we cube root each side and we get that r equals 3. So our common ratio here is 3. All right, that's how you find r. Not that bad. We'll go back to our explicit formula. So we're going to do a sub n equals a sub 1 times r to the n minus 1. Well, we don't know what a sub 1 is, do we? But we can find it really easily, right? Because we know that a sub 2 equals 6, right? And since our common ratio is 3, we know that a sub 1 has to equal 2. And if you're not sure why, our common ratio is 3, we take 6, divide it by 3, and we get 2. All right, so now we can go ahead and write out our formula. So a sub n equals 2 times 3 to the n minus 1, and we know that n is 24. So a sub 24 equals 2 times 3 to the 24 minus 1, so that's the 23rd. Remember, you have to do 3 to the 23rd first, then multiply it by 2, and you get a sub 24 equals 1.88 times 10 to the 11th. Okay, so here, right here is our explicit formula. Okay, we have a sub n equals a sub 1, which is 2, times 3, which is the r, to the n minus 1. So now whatever we want to use for our n, 24, we just plug it into n and we can find out what it equals. Our recursive formula is going to look similar. Okay, our recursive formula, we're just going to say that a to the n equals 3 times a to the n minus 1. Because remember, our recursive formula said a to the n equals r times a to the n minus 1. So here's our recursive formula. And don't worry, we get lots of practice with it. See you tomorrow.